Hello guys, and welcome back to the course. In today's lesson, we are going to learn several properties of functions that we always need to have in mind. The first property about functions that we need to have in mind is the concept of positive and negative functions. We say that a function f is positive in an interval a, b, if and only if for each element x in such an interval, f of x is greater than 0. Analogously, we say that a function f is negative in an interval a, b, if and only if for each element x in such an interval, f of x is less than 0. And we can have a glance of how they look like by checking on these graphs. Now, there are some points on a graph that are more remarkable than others and which are going to be really important as we advance in the course. Now, two of those points are the x-intercepts and the y-intercept. The y-intercept of a function y equals f of x is the point 0, f of 0. Graphically, we can see this y-intercept as the intersection between the graph and the y-axis. Now, not all functions have y-intercepts, but if they do have one, then that y-intercept is unique, because if they have more, then the concept of a function is not satisfied. Now, the x-intercepts of a function y equals f of x are the order pairs x, f of x, where f of x is equal 0. Graphically, we can notice this as the intersection between the graph and the x-axis. Now, we're going to talk about the concepts of increasing and decreasing functions. We say that a function f is increasing in an interval a, b, if given two arbitrary numbers x sub I and x sub I plus 1 in such an interval, then f of x sub I is less than or equal than f of x sub I plus 1. Analogously, we say that f is decreasing in an interval a, b, if given two arbitrary numbers x sub I and x sub I plus 1, then f of x sub I plus 1 is less than or equal than f of x sub I. Now we're going to talk about the concepts of absolute minima and absolute maxima. We say that a function f has an absolute maxima at x, f of x, if given any other point w in the domain of f, then f of x is greater than f of w. Analogously, we say that the point x, f of x, represents an absolute minima for the function f if given any point w in the domain of f, then f of x is less than f of w. Now, the concepts of relative minima and relative maxima are similar to the concepts of absolute minima and absolute maxima, but instead of taking the entire domain of the function, we are going to take a restricted area determined by an interval. We say that a function f has a relative minima determined by the point x, f of x in the interval a, b, if for any point w in such an interval, we have that f of x is less than or equal than f of w. Now, if such a value x, f of x, is such that for any value w in the interval, we have that f of x is greater than or equal than f of w, then the point x, f of x represents a relative maxima in the interval a, b. Now you have learned pretty much everything about the properties of functions. So it's now your time to identify each of the properties that I told you with the following functions, which are graphed. So well guys, as always, see you in the next video.